Okay, thank you, Chris. Okay, let's start over again. Good day to you. Good day, everyone. Thank you so much for joining us today. I'm Nancy Regan. I'm joined by Mark Horton, Chris James, Graham Stephen, and Jesus Safante. And we are the IRCC, the International Reliability Centered Maintenance Certification Committee. We are dedicated to the proper application of reliability-centered maintenance. And so we are here to help make sure that you apply it correctly and get the best results that you can. We've recently launched our RCM certification level 1, which we'll talk about a little more in a little while. Today, we've got planned for Graham Stephen to talk today. Now, we've got a little bit of a technical difficulty, so if we can't work through that, not to worry, because we have got a backup subject, and actually a very important one that we need to talk about. So let's start talking about that, and in the meantime, we'll see if we can get these technical difficulties worked out. So tell us, I guess I should have said right away, please just put in the chat if you can see us and that if you can hear me. And also tell us where you are seeing us from. And maybe behind the scenes, I'll leave it to you, Mark and Graham, to see if we can work out these technical issues. And if not, again, not to worry, we've got a really interesting thing that we can talk about today. Okay, so let's see. Welcome, Bijoy, and let's see, Mohammed, Rafi. Oh, thank you, Rafi. He's happy to be back live with IRCC colleagues. Thank you so much. Thank you for joining us. Okay, so while we're trying to sort out the technical difficulties for what we were going to talk about today, in the meantime, let's talk about something else really important. So when it comes to reliability-centered maintenance, RCM gets a bad rap sometimes, that RCM takes too long, it's too expensive, you don't get the results you want. And that is likely due to RCM not being applied properly and with the right people. Just like anything in life, if you don't understand how to do something, you can end up going down all kinds of rabbit holes trying to figure it out, making mistakes. When you had just done it right in the first place, things, can flow so much easier. And, I've talked to a lot of people who have reported some of the same things. And I know that Mark and Chris and Graham and Jesus, I know that they would agree. So number one, you have to do RCM correctly. And that's one of our missions, is to help people and make sure they know they're doing it correctly. But another thing is implementing the results and then staying on top of RCM, because RCM is not just a one-time thing. Now, you may do an analysis on a system today, and you may not have to review it for several years. But the question often is, how often do you have to review RCM results? Well, the answer is as often as necessary. So if your operating environment changes, operational tempo changes, if you've got equipment changes, any kind of changes to requirements, that's a key point where you would have to go back and review your RCM analyses. So that being said, the reason why this popped in my head is because it's easy for us to relate reliability to our own personal lives or personal things that go on. And one thing that pops in my mind is when we as people feel we need to go on a diet because maybe we've overindulged, maybe during the holidays or whenever it might be, and then you go on a diet, right? And you're like, rah, rah, I'm going to do this. And you stick to the diet, whether it's a couple of weeks or a few months or however long, and you get to your goal weight, right? And you feel great. But then some time goes by. And what happens? Well, I'll speak for my own self, but I'm willing to bet that this happened to some of you out there. Some time goes by and complacency sets in, and then you start eating the tortilla chips in front of the TV at night, or you maybe have a few too many desserts, and before you know it, the weight starts to creep back on. It's the same with reliability-centered maintenance and really reliability in general. It's something that you have to keep up on, something you have to have discipline and stick-to-itiveness to really stay with it, to keep up with your RCM program and RCM analyses and reliability in general. So I don't know, maybe Mark, Chris, Graham, Jesus, do you have any thoughts about this? Or maybe you have some stories in the past where, people get going great with RCM, but then, people get overwhelmed by current events in their lives, business and personal, and the proactive stuff kind of goes to the wayside. Do you guys have any thoughts about that?
I think it actually goes back to the how RCM was originally set up. Really, it came out of the aircraft industry, and that's a big part of the way that they do business is continuous improvement and auditability and traceability. And that's what they've been doing for decades. Really, they don't just do it in maintenance; they do it as part of the way that they do business. And so they decided they need to do it in maintenance, and that's why they developed RCM, to have the audit trail, and they continue review and continue update. And you're right, Nancy. Very few people do it elsewhere, and we all should be, because despite our best efforts, we get better information. It's never going to be perfect. Things move on anyway. So we very much should be updating and reviewing our analyses.
Yes, and it's sometimes it's hard to stay proactive. Especially when I hear all the time from people, we're running from fire to fire, we're this came up and that came up, the compressor is down, and so you're so busy fighting fires, so to speak, that it's hard to stay proactive. But it goes back to the whole diet thing as human beings. If we want to stay fit and keep the weight off, we cannot go to the gym for one day every 3 months and work out for 24 hours and expect the results, right? You have to be consistent, and you have to do it every day, and it's not easy. So none of this stuff is easy. Some of it's simple, but it's not easy. There's a difference between simple things, because it's simple to go to the gym 3 times a week. It's a simple thing to, just have a dessert once a week. But to do that consistently is not always easy, because it takes our willpower, that's speaking personally, but, then we get into the professional area with reliability, and there are all kinds of things tugging at us. Okay, I'm just going to have a look in the chat to see if we've got our technical issue worked out. If not, we'll keep talking about this. Let me see. Okay, all right, so let me just have, a quick look.
Yeah, Nancy, there are so many things happening at an organization at the same time. And sometimes we have a plan to implement RCM, we do the analysis, we do all the things by the book. But at the moment of, let's say, implementing, there are so many things that has to be coordinated, so many resources that have to be prepared for doing the task, for incorporating all the recommendations into the CMMS, other things that we have to do with the engineering department. We have to do changes to equipment. And sometimes I've seen that the ball drops, at some point. So we may have done a terrific analysis. We may have had the best team doing the analysis, but at the time of implementation, many of the efforts fail in there. And I've heard from other colleagues that it takes a lot of, and we know it, by our own practice, it takes a lot of leadership to implement an RCM analysis effort properly. It is not only to just do the analysis itself, but afterwards, there is a lot to do. And as you say, with time, there are changes. We have changes in personnel. We change people from one department, move to the other. We have changes in technology. And if nothing changes, the equipment are aging themselves. So there is a challenge every day, and we have to keep RCM as a living thing, as a living organism. It is rather than being a program, rather to being like a one-time shot. It is a living thing. It is a lifestyle. When you deal with very critical assets, there is something to do every day. And as you say with the diet, once in a while you say, yeah, I'm gonna get a goodie today, but then you have to go back to the again to the norm and go back to being do things by the book. And same thing with resources. We have scarce resources. We don't have all the maintenance people we wanted to have in the companies, so we need to prioritize. And it's like every other thing in life, as you say. We have to have a lot of discipline when we deal with RCM.
Yeah, thank you for that, Jesus, especially the point about, like management or other people. We not only need to get the time and the focus to do what we have to do, but we don't work in a vacuum, and there are other people that we have to deal with also. So yes, 100%. We could talk all day on this, I think. But we've got our technical issues worked out. So we're going to have our keynote speaker, Graham, join us. Let me see. Okay, Mohammed says he can see and hear us. Hello from Saudi Arabia. Mohammed from Egypt. William from Brazil. Hi, William. Okay, all right. So without any further ado, let me introduce Graham Stephen to you. So Graham was certified as an RCM practitioner in 1993. He's been implementing RCM internationally ever since then, both in the military and the civilian sectors. One of his claims to fame is that he had a key role in the production of the UK's Naval Engineering Standard, NES 45, that was very heavily to do with reliability-centered maintenance. And I particularly look to Graham for his advice and his counsel when it comes to RCM applied to electronics. But today, he's going to talk to us about the importance of operating environments. So, okay, Graham, take it away.
Yeah, thank you, Nancy. I'm going to have to apologize to start with because we've had all sorts of problems, and they seem to boil down to I'm using a Mac and everyone else is using a Windows machine. So what I'm going to do is run through the slide set, and Nancy, are you going to move them on? Okay, so I'll
just let me know.
I need the next slide.
Mm-hmm.
Okay, yep. So if you could click on the first one, please. Right. I want to tell you a story. It concerns a raw sugar factory that I was working with in Papua New Guinea in the early 80s. This was long before I knew anything about RCM. What a shame. And I'll explain why. This outfit's right out in the wilds, but right out in deep country. There's a picture there. Next one, please, Nancy. It's in a part of the world where rainfall is measured in meters. I think something like 7 or 8 meters a year. It is incredibly wet, and it all happens during the wet season. The dry season wasn't too bad. And of course, sugar cane production is very seasonal anyway. Next one, please. It's an interesting process. This has nothing to do with the RCM, but I found the whole process interesting because the fuel to keep the whole process going is provided by the sugar cane itself. It's the fiber within the cane, and providing you've got or the agronomists have got the fiber and the juice side of it the proportions correct, the whole process is self-sustaining once you've got it going. It's very clever. Next, please. The principal product was raw sugar, the sort of thing for which, certainly in the UK, you pay a premium, which always amuses me because it's actually the first of the refining processes, if you like. And we bagged it into 1 kilo bags and 50 kilo sacks. Next, please. One of the byproducts of the raw sugar process is to produce vast quantities of molasses, which we used as the feedstock for a distillery, and we sent ethanol down to the nearest town, which was Ley, about 200 kilometers down the road, and it was used as a fuel, motor fuel additive to reduce foreign exchange. Right, next, please. One of the things about the process is it requires vast quantities of water as part of the process. So, if you like, water is the lifeblood of raw sugar production. And we extracted the water via a deep well system, a borehole pump system. Next, please. Simple system. It's a motor and pump, motorized pump, drop down a hole, something like 30 meters deep, and then it's piped out to the tank. Thank you. And of course, it's electrical, so there's quite a lot of electrics involved. The supply breaker and the electrical distribution and the starter. So.
Oh. Sorry.
Hang on, that's all right. And that describes the tank itself. That's all right. We can move on to that.
Good to
Next,
go?
please. Yeah.
Mm-hmm.
So nothing very special about that. And in fact, the whole process is extremely agricultural. However, we produce something like 2,500 tons of sugar every year. No, I might have got that wrong. Actually, it's rather more than that. But anyway, and given that the factory is entirely dependent on this water supply, if things went wrong, there was a problem, a big problem, a pounds and pennies problem, if you like, putting it into sterling. Next, please. Oh, right. No, go back. Yeah, one of the things I'm going to apologize for is this is all in PowerPoint, but actually the original file was in Keynote. So I think we've got a few problems coming up with readability, but I'll talk it through when we get there. Right. If we had carried out an RCM analysis on the borehole pump, it would have looked something like this. There's a function to supply water at not less than a certain rate. I've said 300 liters a minute. I'm not sure that's absolutely right. And there are two functional failures that drop out of that, of course. One, that it doesn't do it at all. And the second one, of course, is it doesn't do it enough. And if you looked at some of the failure modes that one would expect against those functional failures, could we go on a little bit further, Nancy?
Mm-hmm.
Oh, right. That's not coming through.
Wait, hold on. It might be. No, it's me. Hold on.
Oh, there we go. That's it. That's fine. Yeah.
Okay.
Yeah.
Whoa. Okay. All right. Sorry.
That's fine.
Okay.
So there are a quantity of failure modes which one might reasonably expect to see against unable to supply water at all. And they involve electrical problems, pump problems, pump motor problems, all those sort of things. And I put those there as a for instance, really. And then for the functional failure unable to supply enough or the correct rate, there is one principal one, and that's that there's problems with the pump impeller, usually through wear. Can we go on to that?
Mm-hmm.
Okay, that'll do. Stop there. That's fine. So this would be my putative list of failure modes for the pump, which is standalone. And if you look at the sort of tasks you might expect to carry out on this, can we go through those? They come up one at a time. Yeah, we normally analyze power supply as separately, and it usually falls within the functional and analysis group of, to distribute power, electrical power. So we in this case, we've said analyze separately. Next one is supply breaker fails open, no schedule maintenance. For similar reasons, the pump starter, there's probably not a lot you can do to forecast its failure or to prevent it. So you deal with it when the problem occurs. So that's NSM as well. Next one, please. Right. There probably is something you could do for the pump bearing. And the usual approach is to deploy some sort of vibration analysis, that sort of thing. The problem is this pump is 30 meters down, so you've got to lift it to do the VA on it, and you would do it at an appropriate interval driven by the P2F interval that you're looking at. I've suggested 3 months. It's going to be of that order. It's not minutes. It's not hours. It is probably a matter of months because it's running in a fairly benign environment. Next one, please. Pump motor fails. Yes, electrical problems, broadly unforecastable. No schedule maintenance, deal with the problem when it occurs. Next one, please. Right, and the pump impeller wear is actually quite easy to manage, but it requires quite a lot of organization. What we would do is shut off all the offtakes from the tank I showed you earlier, run this pump and time how quickly the level rises between two known points. And that will give you an estimate of the throughput. And you do that at an interval which would give you sufficient warning to do something about it before the whole lot comes crumbling down. So I've suggested we carry out a pump capacity check of that sort, and probably done every couple of months. This process, incidentally, the sugar process, runs for about 6 or 7 months of the year, and the remaining months is, well, it's an opportunity to pull everything to bits to see why it's working. Sorry, pardon my cynicism. Move on. Right. It wouldn't be unreasonable then to say, well, we could do with more than one pump because we got all our eggs in one basket. Let's have 2. So we'll suppose that we've got 2 pumps here. Next, please. And the approach that I adopted, I regret to say, as the electrical engineer at the time, was okay. So we've got 2 pumps, so we got twice the amount of maintenance. So we'll draw up twice as many job cards in a sort of tickler system that I ran, and that sounded like quite a good idea. I wish I'd known about RCM at the time, because actually it's much better than that. Let's move on. So I'm going to suggest that we've got 2 pumps now, and we're going to use those pumps in a duty standby type of arrangement. So the duty pump looks like that, and if you click on one, the standby, physically the same sort of arrangement. These 2 pumps are actually about 1/4 mile separated, and both of them are about a mile, getting on for a mile away from the factory itself. So it's to get people out there and do all these things to them requires quite a lot of logistical effort. Right, can we move on? Now, if we adopt a duty standby arrangement, do the RCM analysis on that, you'd expect to see the functional failures and failure modes for the duty pump to be broadly the same as for the pump that was on its own. And incidentally, I should just put a caveat in here. I'm only talking about the primary function of the pump, that is its ability to pump. I'm not considering the protection, be it electrical, mechanical, all these other good things. There's a containment issue as well. All of those would also be swept up in the proper RCM analysis. That's not what I'm concerned about here, though. Let's move on. And if we look at the tasks, now these need to be brought up one at a time, please, Nancy. Analyze separately for pump power failure, as before. Supply breaker fails open. Again, nothing we could do about that. No scheduled maintenance. Ditto pump starter. Yeah. Pump impeller blocks. Again, broadly unforecastable. Pump bearing seizures. If you remember, we said before that we'd lift the borehole pump and carry out a VA on it. It's not really worth doing that now, because if you have a problem with the bearing, all you do is you switch over to the standby pump and then you lift this thing and fix the bearing. So no scheduled maintenance for that. Move on. Pump failure motor, pump motor fails, NSM for the same reasons as before. And then when we come to pump impeller wears, again, so we find that it's not man enough to sustain the factory's requirements, so we run the other pump and we lift this one up and we fix the pump impeller. So again, no scheduled maintenance. So in summary, for the duty pump, it's pretty well no scheduled maintenance all down the line. Next slide, please. In contrast, if you look at the standby pump, I've gone blank. Go on, next slide.
Mm-hmm.
Thank you. Right. If you carry out an RCM analysis on that, the initial part of the analysis is going to look something like this. It's to supply water at that rate in the event of failure of the duty pump. It does need to be predicated on that. Functional failures, unable to do it at all in the event of. And the second, the functional failure is 7B. I've assumed it's function 7. It's not necessarily that. 7B, unable to supply water in the event of. All right, let's look at the failure modes again. They look broadly the same. Keep going. Yeah. Yeah, and again. Yeah, one more. Right. Surprise, surprise, the failure modes are not that much different from the other because it's the same sort of pump. It operating in the same sort of environment, just being used differently. Let's look at the tasks then. Analyze separately as before. Right, 7A2, pump breaker fails open. You wouldn't know about it unless you went and checked it. So we'd carry out failure finding on it, the failure finding task to see if it's still okay. Same with pump starter. Next one, please. Impeller blocking. Well, yeah, we can run the pump, see if it's blocked. Pump bearing seizes. Well, this pump is rarely used, so where the bearing could seize, possibly through lack of use, but I'm talking about pump bearing wears through, because of being used. That's less likely, so I've suggested that's not plausible. Next one. Excuse me. Failure finding for pump motor fails. And the impeller wear is less likely if the pump is not being used or not being used very much. So next slide, you'll see that all of those boil down to failure finding. And what we do is just run the standby pump periodically. And I use the term periodically advisedly. We run it to see if it works. And then if it doesn't work, then we obviously deal with the problem itself. All right, can we move on? It's probably worth pointing out that if the only failure mode in 7B was pump impeller wears, which is not plausible, then the whole functional failure is not plausible. Well, there's a surprise. You could probably assess that when you're doing the RCM analysis and at the functional failure stage. Okay, let's move on. Right, this is where the text is going to catch me out. I like this example. By the way, it's known in the RCM fraternity as the 3-pump example because it illustrates some really important issues. Can we first move on to the first slide? Or
Yep.
the next slide.
And if we want to pause for a second, I can open up the revised version. Do you want to pause for a second, Graham?
Oh, the revised version, what, the one I've just sent you?
Yeah, I have a fixed file. Can we pause
Yes,
for a
okay.
second?
Yeah,
Because
this is a natural break.
actually,
Yeah, absolutely.
it would be a great moment to pause. Number one, to mention if anyone has any questions, please do put them in the chat. But also, Graham, you mentioned a few things to me that really rings a bell. So number one, I'm doing two things at once here. So let me open this and then I'll give my thoughts. Number one, you've used terminology like P2F interval and failure finding. This is obviously RCM terminology. And it's just another reminder to us that reliability in general, reliability-centered maintenance has its own language. And so it's very important that we understand the process, and not just the people who are doing analyses, but also people who have to implement the results and live with the results. It's important that they understand that language too. And the other thing is that, which I think is what you're getting to now, is the essence of reliability-centered maintenance and consequences. So a pump is not just a pump is a pump. It depends on, consequences can be different. So, okay, so here we go. I've got it here. So I didn't mean to steal that thunder, but here we go. Now
No, absolutely. No, thank you. And this is
I'm
the
all
danger.
sorted out now. Okay.
Yeah, there is a lot of jargon associated with this.
Mm-hmm.
You're absolutely right, which simply reinforces the need to become familiar with the jargon before you do it for real.
Yep.
Yeah, no question. All right. The first issue is that this example illustrates that RCM is about asset management and not necessarily about asset care. We make the distinction between those two. I mean, clearly, if we're talking about the running pump in the situation where you've got two, the duty pump, you're not doing anything to it. So you're not doing much in the way of asset care, but you're doing everything in terms of asset management. Okay, next one. And following on from that, simply applying manufacturer's recommendations doesn't make sense. The manufacturer would never have recommended no schedule maintenance for his pump. Yeah, so you've got to see it in the context. I'm not denigrating manufacturers' recommendations, but on the other hand, one's got to look at what's being asked and ask why, and is it worth doing in RCM terms? Okay, next one. There's often a thought that, well, a pump is a pump, and what you do to this pump, you'll do to that pump, because that's what pumps need. That clearly is not the case. And we've got three examples: the standalone pump, the duty pump, and the standby pump have got different maintenance, simply because the consequences of failure are different. Okay, next one. So therefore, you have got to apply some form of formalized consequence evaluation before you can say, yeah, this task is going to cut the mustard. We need to think about it. We need to decide whether or not that is true. It's a systems engineering issue, this. You've got to look at it in the whole. All right. Next one. Yeah, highlights the opportunities for more cost-effective deployment of resources. I've already used the phrase, and I've come across so many organizations where they pull things to bits to see why they're working. It just seems such a waste of time. And one's got to ask why. Why is it being done? Much better to do it only when it's needed. And most electrical engineers, I would say, is, you know, if it's working, leave it alone. Don't dive in there to upset an otherwise stable system. And for the RCM aficionados, of course, that is all about failure pattern F, isn't it? All right, next one, please. Yeah, rather a lot of writing in here, but what this is about is, well, if you're dealing with the so-called default tasks, that is no schedule maintenance and schedule failure finding, you have an opportunity for lumping things together. So I've shown you in the case of the duty pump, what, half a dozen failure modes, 1A1 to 1A6, I think it was, doesn't matter which all ended up with no schedule maintenance. So you could actually say, well, hang on, the whole pump is NSM. That would be a valid way of dealing with it. Okay? Oh, well, no, sorry, just before I go on from that, conversely, if we're talking about failure finding for the standby pump, we've got a whole series of failure finding tasks that need to be done. If you could do them at the same time, simply by flashing up the standby pump and see if it works, you're doing a single failure finding task. And of course, in our case, out there in New Guinea, the failure finding task of that sort would have been done by the production department. So with a sort of monetary hat on, that's good news, because it doesn't come out of your budget as the maintainer. It's being done by the other guys. So there's lots to be said for it. Next one, please. So many organizations where they have lots and lots of redundancy adopt an odd even day regime. In the bad old days when I was in the Navy, the first job we did at the change of the watch at midnight was to swap machinery states over. So half the machines would be shut down, the other half would be flashed up again. And we're running, we were running an odd even day regime. And if you think about it, all you're doing is you're applying the same sort of consequence of failure, or broadly the same consequence of failure, to both. So therefore you're in for quite a lot of extra maintenance effort. Whereas if you adopt a running standby regime, this running and standby pump in this case I've been describing now, for the running pump there's nothing to be done, only deal with the problems when they actually occur. So that costs nothing. And as I've already said, the standby, checking the standbys periodically, is done by someone else, and they have to pay for it, not me. So that's got to be a good thing for us. It's a rather parochial view. Right, next one, please. I think this needs thinking about. I've said that the standby pump would have to be run periodically. And I was choosing my words carefully, because how often you run the standby pump is dependent on a variety of factors. One is the reliability of the pump itself. The other is actually the reliability of the other pump. And the third variable, which is quite often overlooked, I discovered, is how much risk are you prepared to take that both of those failures have coincided. And if you're able to quantify that, it's very easy to come up with a failure finding task or failure finding interval. The task itself is simple. And that boils down to the statement that actually this risk is entirely manageable, dependent on what level of risk you're prepared to put up with. Okay, next one, please. Yeah, I put this one, I had a rush to the brain. Of course, if you were a designer, you might be tempted to say, well, let's have a bigger tank. that would be quite an enlightened way of dealing with it, because if you had a bigger tank, you could cope with a greater degree of failure before the factory stops. So I doubt whether that is ever taken into account in the design process. I know for sure it wasn't in our case, but it's something to think about, which sort of leads on to that there is a derivative of RCM, which John Mowbray was working on, called reliability-centered design, and this would be one of the issues that would be taken into account. Brilliant. Let's move on then. I think that, oh yes, right. You have to go to ask for questions, but before we do that, all of this 3-pump example, as I say, is encapsulated in the RCM 3-pump example, which I find is a very persuasive approach. And when I talk to customers about this, or when I used to talk to customers about this, I always like to trot out the 3-pump example because I think it speaks volumes. And I've tried to show that not only is it defensible from a technical point of view, but it also brings all sorts of extra benefits, which I've just tried to describe. So at that stage, I think we could take questions. I'm sorry, it's gone on rather a long time.
Oh, this was great, Graham. Thank you. So yes, if you have any questions, please put them in the chat. Jesus, I'm wondering, you mentioned something about unnecessary maintenance, how unnecessary maintenance recommended by an OEM can cause failures. Will you elaborate on that? Maybe we can get Graham's thoughts on that.
Sorry, say that again, please, Nancy.
Yeah, great. Jesus has a comment and a question that he'd like you to elaborate on. So, yep, let's let him. Yep.
No, thank you. I was just reading that
okay.
and not paying attention because I can only do one thing at a time.
All of us can only do one thing at a time.
So, Graham, we can do 5 things at a time because we are 5 people here.
Yeah, maintenance-induced failures. Well, we all know it happens. I have actually had a personal example of that. I have a Skoda. It's done a Skoda Yeti. It's not done very many miles. It's actually my wife's car, but I took it in for its annual MOT, and the guy looked at it and said, "Yes, well, that's fine. Its car's fine. It's almost new. I mean, it's done 20,000 miles, if that." He said, however, the handbook says it after something like 50,000 miles or 5 years, you've got to change the cam belt. Now, you don't mess around with the cam belt, you change it. And I said, yeah, let's do it. It was jolly expensive. Anyway, a couple of weeks ago, my wife said, every time I pull away in the car, I get a message, an ESP. Is it ESP? Oh, no, anyway, it doesn't matter. 3 letters in yellow on the dashboard. So I took it in by a young lad round the corner who's an absolute whiz on this thing, and he had a box of tricks which he plugged in. He said, "Oh yeah, you've lost one of the sensors that feeds the engine management system." So he ordered up a new one, put it in. It didn't cost much, and he said, "That's very odd. It's broken. The sensor's broken." He said, "There's no way that it would normally break, actually physically parted." He said, "However, you have had a bit of work done in that area. I see that you've had the belt changed." And guess what? You know, the act of changing this wretched cam belt has actually caused the problem which I then had to deal with shortly afterwards. Maintenance induced, no question. And you could probably all think of examples, and it costs money. So, you know, as I said before, the electrical engineers always say, if it's working, leave it alone. Yeah, I feel quite strongly about that. Yeah. Okay.
Yes, excellent.
We got any more?
I don't see any other questions, Graham. So a couple of things that really resonated with me. Obviously, the point of your presentation was that, operating context really can matter quite dramatically. That what we were taught by John is that the essence of reliability-centered maintenance is managing the consequences of failure. And that's one of the strong points of RCM, is that when we do our FMEA correctly, we write functions, functional failures, failure modes, and failure effects. That allows us to properly assess failure consequences. And you said something else, Graham, that resonated with me. You talked about risk and that you can never have never. And, because we live in the real world and not fantasy land. And really, that's what we do as responsible custodians, right? We manage risk.
Yeah. And of course, it's very topical now, isn't it? When we talk about how likely you are to catch COVID or that sort of thing. You just have to see it in context. However many people get, I regret to say, killed on the roads around here. There's no such thing as no risk. So one's just got to see it in context.
Yep, exactly. I know, Mark, Chris, Jesus, do you have anything to add?
I've just been impressed in the past by how much emotion comes into this sometimes. That you can present this academic case for why you should have take into account the operating context, and everybody nods and says, yeah, that's great. And then you go through an RCM analysis and you actually do the job and say, well, in your context, we're saying you move your maintenance from where you've had it, perhaps with the OEM maintenance for years, and here's the package that you need. And it's sometimes, just like the 3-pump example, you're shifting it from something that, okay, for whatever reason, actually did work, but cost a lot of money and perhaps caused problems. And then you're shifting it over to something that actually takes the context into account. And then the problems start in trying to get it implemented. Sometimes that emotion actually stops the RCM analysis from being implemented. Maybe it's just humanity. We don't like taking the risk. We don't want to be the ones who say, yeah, we need to change from manufacturer's maintenance ×2 to the duty standby, where we might just leave one of these pumps to fail. And I can remember in Qatar having exactly that argument, having run a 3-day course for all these guys, and they accepted the pump and thought it was a great example. And you come to something that's almost identical on their own plant, and they're saying, but we can't change that. They went down all the issues, warranty issues. No, it was old enough that warranty wasn't an issue. Are we going to have the right people available? We can have instrument technicians where we need them. Well, yeah, actually we are. And we went down this checklist, but in the end, there was just an enormous emotional resistance to it. And I just throw that out to everybody and say, how have you managed to get over that sort of resistance where you hit it?
Yes, you're right. And it's not only emotional, but it's also hard financial considerations. One of the studies that I did it with the manufacturer for a variety of reasons. One of the later classes of submarine was going to have a new piece of equipment in the back end, and I was asked to facilitate an RCM analysis with the manufacturer, who was contracted to provide an RCM analysis. And anyway, we did that. And about a year later, somebody who I know very well had been auditing some of this stuff, come across his desk, and he said, oh, look, there's a study, it's got your name against it, but I don't recognize it. I can't believe you would have done that, because we all have our own style. And he said, I see your name on it, but I don't see your stamp on it, if you like. And it turned out the manufacturer changed it all after we'd done the RCM analysis. Because you can't do that, take all this maintenance out, we'll lose money. I would guess that's what he said. Anyway, the fact is, all sorts of rubbish was put back into the maintenance regime. Totally nugatory. Waste of time.
Another thing I think is quite interesting about this example is that if you think about it, RCM was designed to determine what maintenance to do in the aircraft industry. But perhaps a bigger, and obviously you have the justification for the maintenance that you do, and a lot of that might be in the failure effects and the consequences and everything like that. It's all in the information worksheet or the FMEA. But perhaps a bigger thing that you're doing at times in RCM is actually justifying not doing maintenance. And that's almost the more difficult decision to make. And of course, once again, a lot of the justification for that would go in the failure effects. If you've got various alarms, or you've got various standby, or you've got spare capacity, or whatever, or you've got time, a lot of that information will go in the failure effects and will justify the fact that you don't actually need to do something, even if you could. The fact that it might not be worth doing. And I find it quite interesting that, of course, that wasn't why RCM, I suppose, originally was designed and was set up, was invented. But it's actually a more difficult call is to say, or a more difficult thing to demonstrate or to prove is not to do something rather than to do something. And of course, RCM is used.
The thing is that in RCM we have to justify everything we recommend. Some people tell me, Jesus, how do you think that the maintenance program would end up after we finish the analysis? I don't know. Let's go through the operating context. Let's do the FMEA. Let's go to the failure effects, and then we can tell you how you will end up, how the program will end up. So sometimes we have to do a lot of condition monitoring. Sometimes we have to recommend a lot run to failure, depending on the operating context. So the thing is that we can't use the copy and paste engineering, because we do RCM for what the equipment, let's say, does, rather than what it is. So a pump is not a pump, so it depends on what it does. So if we were going to apply maintenance for a pump, like all the pumps are the same, so we are wasting a lot of resources. We are wasting a lot of energy, and we wouldn't be doing, as Graham said, asset management. So we will be doing more maintenance and maybe a lot of unnecessary maintenance.
Yeah, and if you look at in the Nolan and Heat report, they said that the link between maintenance and safety was found to be really quite tenuous. And, up until then, it was thought the more maintenance you do, the safer your assets are going to be. Just not the case. Failure pattern F again.
Excellent. Well, thank you. And Lucas, thank you. Graham, Lucas says nicely done. And he also makes a point when we were talking about operating environment, I think, is that in operating context, is he mentioned, especially when the context includes things the owner isn't happy about, such as undesirable operating environments, poor facility support, etc. So definitely something that definitely has to be dealt with.
Yeah.
So yes, thank you for that, Graham. So before we sign off, let me just quickly share our website. So again, we are dedicated to the proper application of reliability-centered maintenance because it's so important to do it the right way so you get the maximum benefit from the process. And so right now we've got level 1 certification up and running. It's ready for you to just hop on, take the 30-minute, 30-question online multiple choice exam and show that you understand the basics of reliability-centered maintenance. Show that you understand what the process is all about. So it's super easy. All you have to do is go to, let me put up the website here. You just go to rcmcertification.org. You see it on my screen, and you can just click on the Get Level 1 certification now, and that will take you to the purchase page. It's $99 US, and you can just sign in, purchase access to the exam, and take the exam. You need 80% to pass, and then Mark will send you a a certificate showing that you're certified. And if you buy it today, but let's say you want to take the exam, maybe you've got an RCM course coming up in the next couple of weeks, you'll have up to a year to take it. So no worries about that. A good point to make is that you do need a good, strong introduction to reliability-centered maintenance. Not just kind of like, browse the internet super quickly. The questions are designed to, make sure that you understand the basics. Any thoughts from anyone about that? Okay, so let me stop sharing. And we'll leave you with this. We will definitely be coming live again, without a doubt. So if you go to rcmcertification.org/subscribe, right now you'll see the banner for today's talk. But that's okay. Just enter your details in there and you'll be on our mailing list, and we'll let you know when we're going to come live again. So we thank you all very much for joining us live today. Graham, thank you so much for your presentation. It pointed out so many important points about not just RCM, but about maintenance and reliability in general. So thank you everyone for joining us, and do go to that subscribe page, and we'll see you next time. Bye-bye, everyone.